All right, finishing up my last two examples. So, person of mass 70 kilograms is sitting on a sled. The two people are pulling her with two different ropes as shown. Determine the acceleration. So what we need to do is we need to calculate the unbalanced force here, because we know that unbalanced force equals mass times acceleration. We know what the mass is. We know it's 70 kilograms. We're looking for acceleration, so we got to find that unbalanced force. Unbalanced force is the same as resultant. So we can look at it in terms of, I can call this one force 1, this one force 2. So if I take force 1 and I add force 2, I will get my resultant. My resultant is just unbalanced force. So I'm just shifting terminology. Resultant is kind of the generic word. In physics, it becomes unbalanced force when we're talking about forces. Using your vector knowledge, you know that F1 will be 50 cos 40. I plus 50 sine 40 J. You know that force 2 will be 60 cos 25I minus, and that's because you would have to go down to get to that head, 60 sine 25J. Once you have that, you can just go ahead and do the calculations. And we find that the x component is 92.7I, and the y component, when I add it up, it is 6.8J. I need to find my magnitude, because I need to know how big is that unbalanced force. So it's the 6.8 squared plus 92.7 squared. I don't know why I changed up the x and y. Doesn't really matter. Squared, square rooted. So I get 92, let's call it 93 newtons, keep life a little easier. The angle at which it's being pulled, tan inverse of the 6.8 over 92.7. So we find the unbalanced force then, the angle that we're looking for here, should be pretty small, and it is 4.2 degrees. So from that, I'm going to return back to my, so I guess this is step 1. Over here would be step 2. Okay, return over here. I know my unbalanced force is 93. I take that 93 and divide it by 70. I get 1.3 meters per second squared. Now to find my direction, I know that over here my x component's positive, so I'm going to head east, which makes sense. They're both pulling toward the east. 4.2 degrees. And because it's positive 6.8, whoever person number 1 is pulling with more force, pulling them upward. So they're actually heading a little bit to the north. So they're not actually heading straight to the right. They're actually heading kind of in that east-north direction upward. So therefore, the acceleration is 1.3 meters per second squared, east 4.2 degrees north. And there we are. One last example, similar lines. This one's actually more important, and I'm going to tell you right now. I'm going to give you a fairly significant hint here. A question like this is on the test. All right. Always poorly done. I'll let you know ahead of time. This is a question that's on the test. It's either going to be a lawnmower or it's going to be someone pulling a wagon. I don't get overly creative when it comes to this one because I want people to have a shot at getting it correct. So free body diagram is hugely important here. All right. Lawnmower. So Ian's pushing down, and actually I'm going to make that a little bit larger over here. Ian is pushing a lawnmower with 100 Newton force down a handle. All right. So there is the applied force of 100 newtons. And if the handle is a 40 degree with the ground, there's a resistive force of 75 newtons. Determine the acceleration of a 45 kilogram lawnmower. All right, so need to calculate a couple things here. I know force due to gravity is something I need. So force due to gravity is mass times gravity. So that's 45 multiplied by 9.81. So when I do that calculation, we get 45 times 9.81, 441.5 newtons. So I know that force. Now, also, because they are pushing downward, okay, that means that there will be an FAY. Okay, very, very important. So they're pushing downward on the handle, so there will be an FAY involved here. I'm going to calculate it anyway. We're not going to need it for this particular question. When we get to the next topic, it becomes more important, but I'm going to calculate it anyway just to get you in the habit of doing it. So FAY would be, the formula is the magnitude of the applied force sine theta. So 100 sine 40. So 100 times 40 sine equals 64.3 newtons. We also need to know FAX. We got to know how much force is actually being pushed, or what force they're pushing with in the x direction. And that is going to be the magnitude of the applied force cos theta. So that would be the 100 cos 40. And calculating that, I get 76.6 newtons. Okay. So when you look at this, there is a normal force. I don't need to calculate it for this question, but I'm going to because it is important. The normal force in this case is going to be Fg plus Fay this time. I can see that from my free body diagram. So that means 441.5 plus Fay was 64.3. So we end up with an 8, 5, and 45.8 newtons. That's going to be up. Okay, so we want to find the acceleration. Now, we know the lawnmower. It doesn't matter how hard you push on the lawnmower, it's not going to go into the ground. So we are really looking for the x component here to solve this question. And that's why we didn't really need that information. I just want to show you that you do need to calculate it, and it's going to become important when we head into the next topic. So the unbalanced force is coming straight from the x component. Okay, so your x component. Again, I always assume to the right is positive. That's my convention. So that means I'm going to take my FAX value, the 76.6, minus the force due to friction, which is 75. Mass is 25, and the acceleration is there. When we look at this is going to be a very small value. 1.6 equals 25A. So if we do that division, it's going to be very, very small. And it actually turns out to be 0. So the acceleration is 0.064 meters per second squared. And according to my diagram, it's going to the right. So when you interpret that answer, because the acceleration is so small, we can almost say that the lawnmower is being kept at a constant velocity. Okay, because the acceleration is really, really small. So therefore, the acceleration, so the clinical answer, the answer that you give me without thinking, the acceleration is 0.064 meters per second squared to the right, or the lawnmower is being pushed with uniform motion or constant velocity. Uniform motion or constant velocity. And that's you just realizing that, hey, this acceleration is so small, so insignificant that it's pretty close to 0, so it's almost being pushed with uniform motion. All right, so the questions here will give you a chance to practice with the vectors a little bit, calculate forces in 2-dimension or unbalanced forces in 2-dimension. So if you have any trouble with the note or you want anything re-explained, make sure you ask in class. Make sure also you do complete that homework in class, and if you have struggles, please let me know.